So today we are going to solve 1600 problems. So I'm going to solve these four problems: 1707A to 1698D. Okay, so this is first problem. Dormy is asked to test and contest. Contest I can be tested on day I. The difficulty of contest I is AI. Initially Dory's IQ is Q. On day I, Doris will choose whether to test contest I or not. She can only test a contest if her IQ is strictly greater than 0. If Doris chooses to test contest I on day I, the following happens. If A of I is greater than Q, if his IQ is lower, so Doris will feel she will not wise enough, so her IQ will gonna decrease by 1. Otherwise, if it is equal or IQ is greater, so nothing will change. If he chooses not to test a contest, nothing happens. Okay, so Doris want to test as many contest as possible. Please give Doris a solution. Okay, Doremy. Okay. For each test case, you need to output a binary string s, where s of I is equal to 1 if Doremy should choose to test contest I. If si is equal to 0, otherwise. Okay, si is equal to 0, that c is not gonna test this contest. Okay. The number of ones in the contest should be maximum possible, and she should never test a contest if her IQ is 0 or less than that. Okay, yeah, here we go. So, what we are given, we are just given some an array some contest having this difficulty level. Okay, and we are just given a q. This indicate the contest IQ of some dormy. So if AI is greater, if her IQ is less than the current contest, so IQ will gonna decrease if she test the contest. And if A is smaller or less, so nothing affect to her IQ. Okay, so we are just given our n contest with difficulty level AI. So if she gonna test with this particular contest, so s of I will be 1, otherwise it will be 0. So we have to output the string s. So we have to maximize the number of contests she will gonna give. Okay, so uh, let's solve this problem reversely. Okay, so at the end, if she give the maximum contest, and so the value of q at the end of will be 0. Okay, so let's start with this. So at the end of we found out that we are just given the maximum possible contest as possible, and the value of q we at the end will be 0. Then we are okay. Okay, now let's start. We are just start traversing a array from the behind, from the a of n minus 1. Okay, so at particular a of I, let's say at particular this element, so I'm just coming with q that is for this q, I'm changing the value of this q from the behind. Okay, and the q that is given, that is small q, and we are changing the value that is this, or I will say 12 a term. So I'm just storing the current value of IQ of Dormy's IQ in the temp. So if this value is smaller than temp, okay, at the any particular I, or it is, or the contest is difficulty is greater than temp, so these two possible conditions can be happen. If it is smaller, so I am 100% sure she will gonna test this, so I will output s of I is 1. and nothing will happen to the this temp. If it is greater, okay, if it is greater, that means at this particular at this in this particular context, her IQ is smaller, and I am just reversing the problem. So if it, okay, if at the point when she gonna test at this point, I have to increase the temp. Why? Because I am reversing the problem. I am just solving that initially the q is 0. I am just starting from here. I will check for this I for this contest, and at any point of time I'm just taking the value can be smaller or greater. If let's say I'm just coming up if I'm just starting from this starting with value q, and I'm reaching at this position with value 10. Okay, so what will gonna be effect? So what will be the value of temp at I minus 1 value? Okay, so I will trying to find out what is the value at this position, so that it is we having, let me make it good, this will be fine. This is I minus 1, this is I having this value, let's a of I, and here is some value. Okay, and a of I is greater than temp. If it is smaller or equal to, then nothing will happen to temp. We just go to this position, this I. Now if a of I is greater than temp, I am saying that at this position the temp is plus 1. This is the value of the temp. Why? Because uh, when I am just testing with this value, my temp will comes out this one. Or I'm taking the example that will be gonna make you fine, because this will puzzles you. So let's say its value is 3, here value is 3, this will not affect, here value is 4. Now I'm just starting from the behind with the q is 0. At this point I reach that q is my q is 3. Okay, so I'm saying that if I'm having value q and starting from the beginning, so when I reach to this position, what will be my value of q? So I'm saying if it is smaller, then I have to decrease value by 1 if I'm gonna to test this one. So I have to decrease my value of q by 1. So here the value is q is 4, and I am when I'm tested to this one, so value is smaller, so value will become 3. So if I'm going to reverse, so I have to, when the value is greater, I have to increase the value of q. That I'm gonna want to say. Okay, if you say, let's say if this value is 4, then what will be the value? If I'm saying that okay, if value is 4, then this value will be become 4, because nothing will gonna happen, it will be equal, so nothing will be happen. Okay, so if it is smaller, that mean it is 100% decrease the value of my q. So here if I'm going the reverse, so value will be increasing. Okay, that's it. So that's we have to do. Okay, so we are just we are to see if it is smaller, then it will not gonna have our value, that is q. If it is greater, so we have to increase the temp. Now how much we have to increase? So if initial value is q, so this temp should not be beyond, go beyond the q. It is always smaller, because the initial value that the door is iq is q. So we have to check if we are gonna increase the temp when if it is smaller than q. That's it. Otherwise we said that we are not gonna test with this a of I, this difficult with this contest. Or yeah, this may be problem. What do you think? I'm just taking all the scenarios what you will gonna think, so it uh, will gonna answer your all the questions. Okay, that's why I'm giving all the examples. Or you may think like that, why should I increase on this one? If it is, I'm saying okay, if it is temp is lower, why should I increase this? Or okay, so So why it is the best case, I'm increasing to this solution. So you say, oh, I'm not gonna test with this solution, I'm just putting SOI 0 and moving to next value with the same temp. This may be the case, yeah, this may be the case. So I am saying that, okay, if you are moving with same temp, okay, so let's say it's here the value is 4. I'm taking the same example, the value is 5, here is 4, and temp here we have 4 3. If I'm taking this scenario, if you say, oh, I'm not gonna test with this value, I'm just passing the same value here, this may be scenario. I'm saying, yeah, this must be a scenario. So I'm saying which will gonna be the best solution, if I'm not passing this one, or if I'm passing, if I'm gonna test with this, so my temp value will become 4, I have to increase 1. So here also you will see that in this here, if I'm just increasing here plus 1, if I'm testing with this contest, so I have to increase plus 1. If I'm not going to test with this contest, that s of I am putting 0 or 1. In this, if I'm putting 1, that I'm gonna test with this contest, so I have to increase the value of the temp. If I am putting 0, that means I'm not gonna test with this contest, so I have to don't have to change the value. I'm putting the value 3. Now you can see that here also, if it is I increase the value, so I have greater value. Okay, so there is a possibility of chance that I'm gonna get more value, more contest, okay, which I'm gonna cover up, kind of thing. So if it is 4, so I'm say I will gonna cover up without without decreasing or increasing the value of the temp. Okay, so increasing the value at the first position is giving me the good solution, is giving me the best solution. That's the point, because after that, if value is come out just equal, so it will always give me the best solution. So here, if it is 4 4, so here also s of I is 1. If I'm not put increasing the value, I'm putting the s of I is 0, that I'm not gonna test with this contest, so s of I will 3. So you can say that a of I is, and again the same situation come up, a of I is smaller than q, a of I is greater than my q. Okay, so it is always be the best solution that I'm gonna increase with the first one, the first value I hit, that is greater than. Okay, so this not be the case, you if don't understand, that will be totally fine. This may be arises on some people head, why I'm gonna increasing on this, or why I'm not, because increasing this increasing my value of temp, and it is always good to having a greater temp, greater value, so it will maybe covering the most of the AIs. Okay, yeah, that I want to say. So let's code. What I am given is that I am given n and q, the current value. Okay, so vector of a of I, I am just taking input of all the values. Now I am starting from the last value is temp. I am reversing, I am visiting the array in the reverse order from the last index. So I am just saying if a of I is smaller, temp is greater, I have also put a vector of pair, that is the answer of size of n. Let's say it is the answer of size n. Okay, let's say I'm just always putting 0. If it is smaller than, I have to put s of I is equal to 1. Okay, sorry, not s of I, this is answer, that I am gonna test with this contest. Else if a of I should be is greater than 10, so okay, so I'm gonna put answer of I is equal to 1. and I am increased temp plus plus. But I have to also see that temp should be less than equal to q. It should always be less than or equal to q. That's it. Now I am just outputting my string. Oh, this one. That is my answer. It is not giving me the correct answer. So let's see why it is not giving me the correct answer. Okay. For this one, this is showing the 0 at the first position. So I'm just saying that I'm having the temp is equal to 0 at the last position. If I am having the value of a of I that is smaller to this, then I'm increasing. Oh, plus 1 should be less than equal to q. Let me test with this. Yeah, it's going good. Yeah. Why? Because if I'm not checking for this one, so it will become temp will become greater than 2. Okay, so I have to check if I'm adding plus 1, then it is less than equal to q. If it is, then okay. So let me submit this. Oh man. Yeah, running on 17. Yeah, got it. So this is the second problem. Good key, bad key. We have n chests. The ith chest contain ai coins. You need to open all the chests in order from 1 to n. There are only two type of key you can use to open a chest: a good key, which cost k coin to use; a bad key, which does not cost any coins but will halve all the coins in each unopened chest, including the chest it is about to open. Okay, so the half operation will round down to the nearest integer for the each chest half. In other words, using a bad key to open the chest, the ai value will come this. Any key, both good and bad, breaks after usage. That is okay, one time use. So you need to use in total k keys, one of each chest. Initially you have no coins and no keys. If you want to use a good key, then you need to buy it. During the process you are allowed to go into the debt. Okay, for example, if you have one coin and you are allowed to buy a good key of worth 3, so your balance will become -2. Okay, find the maximum number of coin you will be get after opening all n chest in order from chest 1 to chest n. So particular in these type of problems, so we have to write all of the possible conditions. We are using the good key and bad key. Okay, so let's say the first is I'm just using good key, and then after that bad key. Okay, so first we have to observe what will be the ranges of the good key and bad key. Okay, so this is the first. If we are just going to solve any problems, so you have to always observe the ranges. So you will see that a of I will become a of I is 9 when I am applying a bad key. So a of I will become 1 by 2. So if I am applying a bad key, all of the unopened will be become a by 2. Second time when applying the bad key, it will become a by 4. So I am saying that value of ai is maximum 10 to the power 9. That is equal to log to, if I am taking the log to, it is come out 29 point something. So I am saying that if I am applied bad key for 30 times, okay, then all the value that is after the the bad key will become 0, because 2's power, if I am dividing any number with 2's power 30, it will become it is always be, I'm saying that 2 to the power 30 is always be greater than 10 to the power 9, so it will be giving me the value 0. Okay, yeah, that's one observation. So in a problem set I can only maximum apply a bad keys for only 30 times, at most 30 times. Okay, yeah, cool. So this is the observation, this is the observe we have. You have to always observe about what is the values are given, what is the different conditions we are given. So first thing to note is bad key can be applied at most for 30 times. Okay, this is the first observation. So we are just having what is the different scenarios we can having. Okay, so we are just applying good key and then all bad keys. This can be a possible key. We are just applying bad key, after that good key. This can be a possible thing. Or we are just applying good key, then bad key, then bad good key, then bad key. So these are kind of different possibilities in which we are going to apply our keys. Okay, so maybe like first bad key then good key, alternative kind of thing. So these are 4 and 5 cases. So in these kind of scenarios, if you fall in these kind of scenarios, in these kind of problems, always you have to write down all the possible cases and you try to eliminate these cases. Then when you are just reaching to only one case, then solve according to this. Okay, that's the question, that's the approach of this problem, is these types of problem. Okay, so let's say I'm using this or this kind of problem. First I'm using bad key and then good key. So let's say I am having a of I, this is a of I plus 1. So here I'm applying the bad key and here I'm applying good key. And the second scenario, here I have I plus 1, sorry, I, my bad. Okay, and here is I plus 1. And in the opposite, we are just applying good key and bad key. So I try to find out which way is good, applying the good key before or bad key before. So if I am applying this thing, so what will be the answer? First of all, the value become half, this value will become half, this value will become half. So the result will become a of I by 2. And for this value I'm applying the good key, so I have to purchase a key that is minus k. So total value I am getting, the total coin I am getting is that much. Okay, if I am applying the good key before the bad key, so it will be give me a of I minus k. And if I'm applying the bad key, so it will gonna halve the value and it will gonna add a of I plus 1 by 2. So the result will become a of I plus a of I by 1 by 2. So, okay. So here you can see that it is always be good, it is always be giving the best result. First we are applying good key and the bad key, so it will be giving the worst solution if we are applying the good key after any bad key. So we are applying good key after bad key, this case cannot be possible. Applying good key after bad key, this case cannot be possible. So only this case is possible. We are applying first good keys and then bad keys. Okay, so we are just filtering this problem from different possibility solution to one possible solution. So we are just having an bite that bad key can be at most applied to 30 times, and first we have to apply the good keys on any number of chest, and then after we have to apply bad keys. So we having a observation that bad keys can be applied at most 30 times. Okay, so you can see that like this almost solve the problem. If you are gonna approach the problem really good, you have good approach, then like in the logic you are only solving the problem. Okay, yeah, so we have only one thing left. Okay, so having this thing and this thing. So we are gonna apply good and then bad. And I'm saying that bad can be applied at most 30 times. That's it. So I have a of 1, a of 2, a of 3, a of 4, a of 5, a of n. So first of all, I'm applying good key to none. So I'm applying to bad key. For here to I can apply at most 30. I know that. So I'm applying at most 30. So it will be gonna apply from 1 to a of 30. That is bad key. Okay, this is the first case. Because after a of 30, all values will be 0. So we are not gonna any collect any coins from all of these keys. Okay. In the second case, I'm applying the good key to a of 1 and applying bad key from a2 to a31. Okay, only 30 keys. In the third case, I'm gonna applying good key to a1 a2 and I'm gonna apply bad key to a3 to a32. Same kind of operations we are just gonna apply. So you can see the complexity, time complexity. So uh, we are going from n up to n, and in each test case we are just going up to 30 elements next. So a n into 30, so it is equal to O of n. So we are just kind of solving these problem in 30 n, you can say that. Okay, yeah, hope so it crystal clear for all of you. So let's have code for this. If you really understand this, so it will be good if you writing the code for yourself. Okay, or pause the video and write the code for yourself. Okay, I am having int n and k, int n and k, scene at comma k. I have vector of the values of a of n. I is equal to 0, I less than I plus plus. I am taking all the inputs, all the coins that a chest have. Now I am making an answer of long long. For int I is equal to 0, I less than n, I plus plus. First of all, I just making a temp variable. So from this I, and I'm going to I plus for the next 30 elements and j plus plus, and I make sure that it not exceed then. So that's a good thing. And I have to another variable that is power of 2. Now it is kind of 1. Power of 2 at each element will become power of 2 into 2. I will say 1 long long. Okay, took 2, and the value which I'm gonna add is that is a of I by power of 2. Here we go. So I will see that answer is equal to max of answer what it will go on temp, and temp is the good key answer, good key answer. So I'm gonna make good key answer gka is 0 initially, and after that gka will be that is a of I minus k. That's it. I'm just output the answer. Simple problem, just a simple, or you can see that it is the problem of div 4. If you solve this problem, you that means you are solved all the problems of div 4. 13 0. Sorry, wrong, it gives wrong answer. So let me see why it is giving me wrong answer. Okay. So 11, but it is giving me 13. So 5. Let me see why it is giving me wrong answer. Okay, I got it. So let me first max of answer comma GK. Yeah. So you can see this answer is changed to 13. Okay. Why it is so? That the last element, if I'm applying all these value with GK with the good keys. So when applying G of n, so that values I'm not taking here. So that value is this one. Okay. So let's see why it is giving 13. We are making by 2 a of, oh, that is values J. My bad. Ah, yeah, good. Yeah, accepted. This is the third problem. Polygraph was recently given a set of n domino. Each domino contains two integers between 1 and n. Okay, my eyes. Can he divide all the dominoes into two sets so that the all the number on the dominoes of each set are different? Each domino must go into exactly one of the two sets. Okay, we are just creating two set. Okay, for example, we have four domino and the number on all dominoes of each are different. Okay, if he has four dominoes, then will be able to divide them into two set in the required way. The first set can include the first and third domino, that is 1 4 and 3 2, and the second set will be the second and the fourth ones, 1 3 and 4 2. Okay, the first line contains a single integer, the number of test cases. The description of the test cases are follows. The first line of each test cases contain a single even integer n, the number of dominoes. Then AIBI is the thing. Okay, let me grab my pen. So we are just given a kind of dominoes, or you can say something, a packet which having two values between 1 and n, and these values must be in a single set. We are just having, after that we are just having two kind of sets, two group, you can say that, group 1 and group 2. We have to put all the dominoes, some are here and some are here, so that each set, like here is the sum dominoes after the end. Okay, and so the values will be 1 4 2 3 5 6. So the values here in this set are 1 4 2 3 5 6. So each value must be different. That's the answer, that's the point. Okay, okay. So here are all values are different, and here also all values are different. So this seems kind of a parity graph, like these graph having like these type of graph. Sorry for the bad. Some, oh man, what is going on? Okay, so these will be this kind of graph, you can say that. Okay, so this is, so what we're gonna do is, so first of all, if you are gonna do approach any problem, so first what we are gonna do is you have to observe the problem statement. Always observe the problem statement, what is given, and some try to conclude something productive. Okay, so that will gonna sort out our answer, that will be gonna filter our answer. So we just reach to a type of a bottom, and then the problem we have to just keep filtering our problem. Okay, so we have, okay, so first of all we have n dominoes, and each dominoes have two values. So at the end of the day we have two n values, and two sets such that all values here are different and all values here are different. So this is, I can say that this is only possible if all the values, that is 1 to n, all are appear exactly two times. Because if it is one appear at three times, so I'm 100% sure that one of the these two set having that value twice. So this is always, so we conclude one thing, that first thing, that is all the values must appear twice. If it is appear thrice or uh, once, that's not gain our solution. Okay, so we simply written no. Okay, so we are reached to our type of first observe. Okay, now another thing, can we observe something else? Okay, let's do problem. So yeah, second thing is, now I'm saying that we having each element twice, so I'm 100% sure that the, okay, I'm now I'm going to make the graph. What graph? That each domino will be each edge of the graph. So let's say this is the domino and having 3 2, so this will be an edge. So I'm making a edge between 3 and 2. So yeah. So I, after making the graph, I am 100% sure that the graph structure was look like something this. So first of all, what I'm saying is that I'm making the graph, so try to make different type of graph. So which type of graph can be possible? So I'm saying that this kind of graph is possible. So forget about the like kind of unconnected graph. Okay, that will be common. That is there. So I'm kind of the structure of the graph of some connected components. This can be possible. I'm saying chain will be possible. This type of chain will be possible, or I am saying a complete chain is possible. So I am, after seeing the problem statement, after reading the problem statement, I am saying that this, I am 100% sure this type of graph are available. Why? That first of all, each element is present twice. Okay, that means there are exactly two dominoes in which that particular number is written. Let's say if it is 2, so 2 is written particularly twice time, exactly twice time. And it is, so I'm saying that all dominoes are kind of a edge for me for this graph. So it's like 2 3 and 4 3 2 4. So each element, each number, each node, that is by, that is I'm saying 2 as a node, having two edges connected to two elements. So if it is connected to two elements, so this is not possible because this is connected to three elements and this is connected to only one element. And this is also not possible. This is connected to zero to one element. This is connected to one element. This is connected to one element. So if it is having exactly appear two times, so I'm 100% sure that each of the node having exactly it is connected to two elements. So I'm 100% sure that this type of graph only possible. Okay, so like I'm just trying to filter out this problem. Okay, so we are just reached to, from this conclusion point, I'm just reached to this conclusion point now. So this can be possible in two ways, like it having odd number of nodes or having even number of nodes, so which is giving me the solution. Okay, so let's say, okay, it will be good enough. So if we are taking an example, oh, so let's say I have a pizza domino, sorry, 1 4 1 connected to 4. This is the first one, Let's say I have second 4 connected to 4 connected to. For the sake of making odd cycle, nodes, odd number of nodes cycle, that is, let's say it is connected to. If someone gonna think like this is having only 3 dominoes, so I'm saying okay, this is, then let's say I have total number of dominoes is 8, another 5 is making another type of cycle. For the sake of to make odd number of node in a particular cycle, I'm taking only these three. So total will be maybe 8 or something even, and those making any another kind of connected graph. Okay, so let me see if it is as our requirement or not, it or like meet our requirement or not. So if I'm making two set, this is x1 to s1 s2, so I'm putting this edge into this one, so it will be 1 for here, 2 for here. So all, if you kind of stuck at any problem, so try to take example at that point and you will gonna find the solution. Okay, now this is coming to that this one, so this will gonna connect to this. So you can say that here the number is twice, so number in a set, particular set, so number is repeated, so this is not possible. And if we are putting this edge into this one, this domino, already said that all the edges are represent a domino. Okay, so here this will be repeated twice. So I'm saying that if a cycle will be there and if its number of node or size is odd, so it is not possible, so it will be not going our answer, so we are not able to meet our requirements, kind of what we are kind of separate into two groups, so that each group having the different values. So let's say if we are having the even values, so we have one odd, one four, one domino, one, yeah, one four, second let's say 2 4, then 3 2, so 2 4, then 3 2, let's say, and 1 3. So we have these four pizzas, 1 3. Same s1 two groups, s2. I'm making that this edge is gone here, this one, that is 1 3. Second goes here, that is 3 2. Third is goes here. I'm taking alternative edge. Okay, so that node 2 will be in the same group having 4 1. So you can see that none of these picture or these number is twice appearing twice. So it is always giving a solution if the number of cycle is, the number of node in a particular cycle is even. So let's see, so we are just kind of reached to the solution. So we are just filtering the hard problem into very simple problem, but we are just giving, we have to see first, we have to check that if we are kind of making a graph, so each size will be is equal to 2. If it is not 2, I'm simply say that oh, this is not will give an answer. Okay, after that I am 100% sure that it is giving me cycle like this. Okay, so I'm just jump into one node and count the number of cycle. So I'm not kind of, if it is so I'm 100% sure the particular graph structure will be like this, so it will not giving me any type of any other structure like this one or this one. So it will be easy to just count the number of uh, but number of node. So I'm just start visiting here and I'm 100% sure I'm gonna visiting again, I'm gonna end my visiting at the same point. So if we are just with the visiting element, with the node visiting, if I'm just also passing my element count variable, it will give me the correct answer because the cycle is this type. That's it. So you can see that we are just filtered this down or cut this down into a simple structure problem, graph simple problem, that we have just count that we are know that the graph will be this type, that of circle type, this type, sorry, oh man, uh, this type, the circle only. Okay, and we need to find out if it is the number is odd or even. That's it, a very simple problem. So let's code together. If you understand this problem, try to code yourself. If you are not, just look in my code. I am having the int n. Then first of all, I need to create a graph that is vector of vector. Okay, I'm making the number of units that is 10 to the power. I'll say max will be 2 into 10 to the power 5. Just say it is not passing include 10. Okay, now I am having int I is equal to 0 I less than n I plus plus, that is ai bi n times. So int, oh man, a b, just see in a b that I am making a graph push back in b. I am defined, yeah, I am already defined. Similarly in the b dot push back, that pb is, oh, I am already defined here. You can see that this pb I am defined here, that defined pb is equal to pushback. Okay, if you are thinking what operation I applied. Okay, so for I'm just checking all the edges. Okay, first I have to check if size is not equal to that the number of node it is connected, the particular node is connected. If it is not equal to 2, I simply say we can't divide, give the answer. Okay, now I need to check about the cycles. So I have to create a vector. If it is true, then I will have to continue this program because that is already rejected. If it is not, I have to make the current type parent is 0. Okay, so I need to create a boolean type visited of size maximum. Okay, so first of all I need to clear this one of first and node, g of I dot size dot clear. So why I'm clearing this? If I'm not clearing this, so if some value are already inserted like in the previous because there are some test cases. Okay, so in previous test case I'm saying that 1 is connected to 2, so g of I 1 include to 2. So if I'm not clear that, so that will be because this is kind of a global element, global variable. Okay, or I will say global vector. Okay, so we have to erase this particular for the particular n elements to use into a particular test case, and visit I have to make it false. Okay, I'm just making a count. So yeah, I need to only int v int it is parent, or it is not required to be parent because I'm taking the vector. So it is good only I'm taking the int, so I am passing it by reference. Okay, so visit of I is equal to of v is equal to I making it true, and I am also increasing the count of the uh, how many node are there or different elements are there. A simple if it is visited, then I will say continue. Oh shit, otherwise add this and pass in the count. So if I'm saying if this particular size count having how many, that is odd number of elements, so I just simply pass out no. See out now. Okay, so if I reach to the end, I will say okay, I'm can able to give the answer. Yes, double no, double yes, no. Hell yeah, man. Yeah, accepted. And one thing you will gonna see is that these are E problems. If you are solving 1600 problems, that means you are kind of solving all the problems of div 3. So this is div 3, and div 3 almost having E or F problems, maybe E or F problems. So you are kind of solving almost all the problems of div E or div 3. Okay. So if you are solving 1600 problems by yourself, it is like kind of a pride for you. You are solving all the problem of div 3. Okay. This is an interactive problem. Initially, there is an array A that is containing 1 to n, where n is an odd positive integer. So size of n is odd. Okay. Okay. Where n positive and there is selected n minus by two disjoint pair of elements. The elements in those pair are swapped. Okay. For example, if I 1, 2, 3, 4, 5, the pair of 1, 4, 3, 5 are swapped, then the resulting array will be like this. I need to ask several queries. You can pick L and R as your choice. It will gonna give you answer in all the element from L to R in a sorted array. So you can 15 queries. Okay. A is fixed. We have to in the 15 queries we have to find out which A is fixed. So first thing, always the first thing, observe from the uh, limits or kind of constant we are giving. So we are saying that we have n is size of 10 to the power 4. So I am saying is that n, the size of n is equal to 10 to the power 4, and the query we can ask at most is 15. So you can say that log of 2 of 10 to the power 4 is equal to kind of 14. Let me wait a minute. Log 2 of 1 is power 4, kind of 14, 13.8, so kind of 14. Okay. So you can see that we have to apply only binary search. We have to give you the answer into a log of n terms. In log of n, we can only use binary search. That's it. So you can see that only how the problem is solved. So you have to only keep your eyes on a binary search. How can we play with the kind of binary search? So how can we apply the binary search in this problem? That's it. You don't have to think about any other algorithm or any other thing. So let me give a solution. We have, first of all, we have 1, 2, 3. Oh man. 1, 2, 3, 4, 5, 6, 7. Odd number of elements. So we are changing n by 2 pairs. Changing means we are just kind of uh, rearranging. So resulting array will be 3, 2, no. 3, 5, 3, 1, 4. Here it will be 2, here 7, here will be 6. So if I am asking for any L to R, for this L to this R, for this L to this R, it will gonna give me 5, 1, 1, 5, 4 in a sorted order. 1, 5, 4. 1, 4, 5. And L to R is from my 2 to 4. L and R from my 2 to 4, and it is giving me. So if I am saying how many are element between L and R between this query, so you can say that this is not 0. Yeah, this is 1, this is 0. So there is only one element in between this, that is L to R, and my L to R is between 2 and 4. Between 2 and 4, how many are elements between this? This is not, because this is less than 2, this is between 2 and 4, this is greater than 4. Okay, so I am 100% sure that answer will be in this range. Why? If the number of elements in a particular range are odd, then I'm 100% sure it will be in this range. The value, that is the integer that is non-touched or non-paired with any other, is present in this range. Why it is so? Let's say if I am taking any range from here to here, so this is the element. So there are only two possible conditions. This may be paired with any other that is outside of this range, or maybe inside of this range. Okay, so what happen is that when it is paired with outside of the range, and I am calculating, uh, so its value will be outside the range, that is represented O, that is outside the range. And if when I'm counting that how many elements are present from L, between L to R, so this will not gonna contribute my answer. Okay, so for the all the pair that is connected outside the element, so that will gonna contribute my result or count by 0. Or the second case, or the some elements which are just paired inside the range. So let's say my range is from 2 to 9 and it is paired with 7. So this is kind of, here will be 7, here is 3. So how many elements will gonna increase my result? That is my result. What is my result is how many elements between 2 to 9 in this range. So this will also be present, this is also present, so it will gonna increase by 2. So because 7 is also between 2 and 9, 3 is also between 2 and 9. So you can see that if all the pairs in between L and R are paired with from any other, my answer will be even. Okay, but if some element that is not paired, let's say it is 7, it is 7 like 8, and it is between 2 and 9, so it will always give me +1, so it will make my result to odd. That's why I'm saying that if the answer is odd, I'm 100% sure that in this particular range my answer is percent. That's it. That's how we are just going to narrow down our range. So I'm taking from L to R. If say if the number of element is odd, that is present between these are, so I'm saying okay, this is the range. If it is not, I'm not going to um, digging that range. That's it. Let's have code for this. This is kind of very simple problem. Okay, so I am having only one element and scene, and simply what we have to do, we have to just output L is equal to 1, R is equal to n, and I'm just applying my binary search. I'm saying my answer is 0 or whatever it is. Int mid is equal to orange will be 10 to the power 4, that is completely fine. I'm gonna check for check for mid, and I have L to R. If it is true, then I will narrow my R, that it will be mid -1, else it will be mid +1. This is simple. What is it? Binary search. Okay, now I just output the answer. I have to apply my bool check function. So I have mid int L int R. So I'm just wanted to find out the range between L to mid. I will say kind of this, and I'm gonna plus my answer. Plus dot, what we're gonna say? Oh man, in C plus plus, that's it. Okay, so always you have to change the line, then plus will work. Otherwise, if you're not gonna change this line, if you not slash n, it will on the same line, it will give you some idleness timeout, idleness limit timeout. Okay, okay, that after that it will gonna be an answer that will be between L to mid, that I plus plus. I'm gonna make a count. I have to X element. So if X is greater than, if it is between the this range, I'm gonna make count. If it is count is odd, I'm say yeah, it is present in this range, return true, else return false. That's it. Simple answer. So how I have to put output the answer? That is using this one. Exclamation. Yeah, that's that. This is the thing is for interactive problem we are not checking by ourselves. We have to submit in this. We always have to submit. Okay, that's the problem with interactive type of problems. Problem with interactive type of problem. It is giving the idleness. Let's see how the idleness is increase. Yeah, idleness limit is increase. So it will be given when you are not applying slash and not changing the line and applying the if not changing the line, this line, the plus output will not be gonna execute, and it will give idleness limiting exceed. The second one is, yeah, for these things, if you are applying, gonna like kind of super fast your code, so you have to always, if in the interactive problem, you have to always uh, comment out these kind of lines. Okay, they will gonna give you idleness limit. I'm gonna think so it will be fine. He accepted. So today we are just solved 1600 problems, and I think so it may be helpful for you. Okay, thank you.